Hi everyone, I'm teacher Yi. Welcome back to our YouTube channel. Today, I'd like to talk about past year question from NMOS 2022, which is about the swallowtail model. Everyone, let's have a look. So in the rectangle ABCD below, the point E and F are the midpoint of AB and AD respectively. We have point E is a midpoint of AB. We have point F is a midpoint of AD. It is given that AE equal to EB equal to 5 cm. Okay, let's try to label it on our figure. So this is 5 cm. We have AF FD equal to 3 cm. AF FD. This is 3 cm. We know that BF and D intersect at the point G. We have BF DE intersect over here, point G. Find the area of the shaded region in centimeters squared. So everyone, how do we solve this question? You see that we are trying to find the shaded region, which is this part, a quadrilateral. How do we want to find it? Oh, some of you might say that maybe we can find out the total area and then we minus out the extra part. Oh, can we do that in this question? Now let's look together. Oh, we can see that the whole figure is just a rectangle. We are able to find the total area. Now look at the extra part. Oh, we can find the area of this triangle. Other than that, we can also find the area of this triangle. But you can see that if we use a total area, we minus out these two triangles. Isn't that? This small quadrilateral right here, it is being minus for 2 times. We still have to add it back. But now, how do we calculate the area for this smaller quadrilateral right here? So, is there any way we can solve this question? Alright everyone, let's look at an example. So now let's say we have this triangle and we say that the ratio of BD to DC, it is 2 to 3. Oh, we are asked to find what will be the area ratio of ABD, ACD. What will it be? It will just be 2 to 3. Because we know that this is the equal height model. Triangle with the same height, we know that area ratio will be equal to the base ratio. But not everyone. You can see that we have this line cutting from vertex A toward the point D right here. What if we try to find any point within this line, we try to connect it with the other 2 vertices right here, just like this. And let me name this point as point E. Hey everyone, you can see that there is a lot of triangle now. Let's say we're trying to find what will be the area ratio of EBD and ECD. What will it be? This is just another equal height model, so it will just be the ratio of 2 to 3. But everyone, you can see that in this figure, there is also another 2 triangles. We have ABE, we have ACE. Now, what will be the area ratio of these 2 triangles? Okay, everyone, you see that just now we got 2 ratio already. We say that for the ratio, we can actually represent as a unit. Let's say ABD, ACD. We say that this is 2A, this is 3A. And for EBD, ECD, we say that this is 2B and 3B. So now you can see that if you want to find out ABE, or this part, it will just be the area of ABD minus out the area of EBD. Oh, so it will just be 2A minus 2B, and then we have 3A minus 3B. The next thing, we extract out the common factor, which is the 2 and the 3 right here. So we have 2 bracket A minus B, we have 3 bracket A minus B. Now, this A minus B can be simplified. So in the end, what we have is just 2 to 3. Hi everyone. You see that for these 2 triangles, the ratio of their area is also follow the base ratio right here, the 2 to 3. And everyone, this model right here is just what we so-call the swallowtail model. Because you can see that these 2 triangles, it has the shape of the swallowtail. So when we have the swallowtail model, okay, we say that we'll try to label out this figure right here. This is S1, S2, S3, S4, which is the area, and this is the length of the base right here. We will come out with the conclusion such that for the area S1 and S2, the ratio of it is equal to the ratio of S3 and S4, and it is equal to the ratio of L1 to L2. This is about the swallowtail model. Now everyone, when we now learn about the swallowtail model, let's go back to our question. So now everyone, in this question right here, how do we want to find a swallowtail model from here? Now you can see that it seems like currently there is no swallowtail model. Now everyone, you see that we need to find out some relationship with the whole figure and also with this shaded region. Now everyone, when we learn about a model, it is always about what kind of shape? It is always about triangle. Now everyone, for this quadrilateral, let's try to make it into some triangle. What if we try to connect the line from D to B? Oh, you can see that now it forms two different triangles, and you can see that everyone, can we find out the area of BCD? It is just half of the whole rectangle. So now first thing first, we're trying to calculate for the area of the rectangle. So you can see that there is a 5 plus 5, there is a 3 plus 3. So to find out the area of rectangle, it will just be 6 times 10, which is 60 centimeters squared. So we say that the area of BCD, it is half of the rectangle. So we use 60 divided by 2, we get 30 centimeters squared. So now, we still have to find out the area of BDG over here. How do we find it out? Oh, everyone, you see that from here, there it is from the vertex B cutting through this triangle B to F. And then from vertex D, there is also a line cutting through the triangle. Now, what if we try to connect the intersection point to the remaining vertex? Everyone, you can see that we got our swallowtail model. So you can see that actually there is two swallowtail model right here. One of it is just like this. It will follow the base ratio of AE and EB. And we have another swallowtail model, which is like this. It will follow the base ratio of AF and FD. Alright, so now let me try to look at this swallowtail model first. But now everyone, you can see that from here, we are still not able to directly calculate the area for our shaded region. Alright, no worry. Let's try to represent the ratio here as a unit. Now let's say our area of BDG, let it be 1 unit. If this is 1 unit, everyone, you see for this swallowtail model, we say that it will follow the base ratio AF to FD. It is 1 to 1. Which means that for this triangle ABG, it will have the same ratio as BDG. So it is 1 unit. This will also be 1 unit. But we still have one part that we haven't found it out. Now everyone, we say that we have another swallowtail model, right? So now let's have a look. You can see that now for these two triangles, it will follow the base ratio AEEB. Again everyone, 1 to 1. Which means that if this part it is 1 unit, AGD right here will also be 1 unit. And everyone, you can see that this is half of the whole rectangle and there is a total of 3 units. So now we know that 3 units it will corresponding to a total of 30 centimeters squared. And for 1 unit, it will just be equal to 10 centimeters squared. And now, we will be able to find our shaded region. So now everyone, we shaded the area of the shaded region. Just now, we already calculated here, it is 30. And now, we say that this 1 unit is 10. So we just have to use 30 plus 10, it is 40 centimeters squared. And this is our final answer. Alright everyone, let's summarize what we learned from this question. So we learned about this kind of triangle. We call this the swallowtail model. So we said that when we had a swallowtail model, the error ratio of S1 to S2 is equal to the error ratio of S3 to S4. And it is also equal to the base ratio of L1 to L2. So this is about the swallowtail model. So everyone, now you can try to do this practice question and you can leave your answer at the comment section below. Alright? So you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.